All right, it's recording. So exercise 2C. Today is a much easier exercise and subsequent exercise is going to be much easier than 2B. 2B is the hardest. So take your time. If you can, just do the fluency only and then move on. Then come back and do problem solving later on. But we'll go 2C. We are working with triangles. Now, there are three types of triangles that you need to be able to label. Label means those notations that you see there. You need to know how to read them. You need to know how to use them. Let's start with the easiest one. All the way to the right. What type of triangle is that? Can I please have someone with their hands up? Amon. Equilateral. How did Amon know it was an equilateral? What are the hints here, Elijah? And how do you know that?
Because of the line.
Good, the dashes. Notice this one has two dashes, and they all have two dashes means that they're all equal lengths. The number of dashes on each one, if they're all the same, that means they're all sides are the same. So equilateral, one of the key things is, yes, all have the same sides. But not only just sides, those symbols here, what do they also all have? Equal angles, very good. They all have equal angles, but specifically, if they have all equal angles, so this angle with one arc, this angle has one arc, this angle has one arc, that means that they're all the same. We do know, though, that all the angles in a triangle must add up to 180 degrees. But if it has to add up all to 180 degrees, and yet all the angles are the same, what must the angle be so that you add itself 3 times to equal to 180 degrees? Can I please have, yes, Losalia? 60. So in the notes here, they all have equal angles, but technically it's 60 degree angle. Okay, because logically 60 is the only answer where you can do 60 plus 60 plus 60 to equal to 180. Or you could have figured it out by doing 180 divided by 3 corners. If you share it equally, 180 divided by 3 equals 60 degrees. So each corner has to be 60. Okay? Let's have a look at the next one. Let's get to the middle one. So we've got an equilateral triangle, but what happens when you only have 2 sides rather than all 3 sides? 2 sides that are equal. What is this called? Let's go with Thomas. Do you happen to know? What's the name for this triangle? A what? No, I guess there is an acute there, but that's not the name for it. Starts with I. William. Isosceles, very good. It's an isos and then celes. An isosceles triangle, that's when you have 2 sides are the same. You can use 2 dashes on one, but that means you have to use 2 dashes on the other. Okay, or you can use 1 dash on either. It doesn't matter. Number of dashes is just easier to identify. So these 2 are the same. Very good. And we can see that when these 2 sides are the same, there is a symmetrical look to it. I can cut this directly in half. That side, left side, is equal to the right side. That also means the angle on the left corner is equal to the angle on the right corner. That's why these 2 have an arc. So 2 arcs. That also has 2 arcs. That implies when they have the same number of arcs, that those 2 angles are the same. Okay, so not these 2 angles, not the top one and the bottom one, not the bottom one here and the top one. It has to be the 2 symmetrical sides. So be careful. Not all isosceles triangles are drawn vertically that I've done. Usually they rotate it. So you have to look for where it's symmetrical. Okay. So what do you fill in? You would say that they have 2 sides the same length and have 2 angles the same. So you got one that is all 3 sides the same. You have one that has 2 sides of the same. And then finally, the last one where you notice all of 3 sides have 3 different dashes implies that all sides are different. What is that called again? Let's go, William. Scalene. That is called a scalene type of triangle. Scalene has all 3 sides that are different, which is marked with all the 3 different dashes. Now you can do 3 different angles, so they all have the 3 same sides, but they also have, I'll say different. Whoops. Different. But they also have different angles. Now you can use the symbols that they've done to show that all three angles are different. You don't have to do it this way. So the students in the other class asked, does it have to be dot, opens, dot, and then across? It doesn't have to be. It could actually look like this. You could draw a triangle. I'm saying all three sides are different. And if I want to say all angles are different, I can do it like this. One arc for one corner. Two arcs for a second corner. So that's saying it's two different angles there. And then I can also do three arcs to say that that's a different angle to all three. Okay, so you can do arcs or you can do symbols. It's up to you. It doesn't have to be dots. You could have used letters like A, B, and C. As long as you are labeling it correctly. So the first skill that I'm looking for is can you identify, but mainly can you read the notations? Okay, so that's the first skill. So in your first exercise, part of your exercise is to determine, based on the notations, what type of triangle do you have. Okay, let's do an example. Actually, they don't have identify here. Let's go to the textbook. They should have it. Oh, they didn't tell you. It's all solving. Aren't you lucky? All right. Well, I guess we're just going to solve then. In that case, we'll jump right into exterior angle theorem. This is exterior angle theorem. The angle on the outside of the triangle, this is called the exterior angle. You can quickly calculate this by adding the opposite internal angles. So the interior angles, the opposite interior angles, if you add these two together, x plus y should equal to z. Now, you can memorize that. Not a lot of students know this, and they can still solve the problem. It's just that there are some problems that require you to know this rule in order to solve that type of problem. So, I'll show you the proof to it. If you get it, great. If you don't, doesn't matter. Here we go. So the exterior angle of a triangle is equal to the sum of the two opposite interior angles. Now let's prove that this is true. Okay, I'm going to do it logically with you. Let's say I just drew this triangle. Like this, like this, like this. Okay? So I'll draw it on the side here for you to see, just separate. This is x, this is y. And let's call this one B. Okay, so I don't know what this angle is. I'm going to call it B, just for the sake of B. Yeah? If I add x plus y plus b, so all the angles in a triangle together, what is it meant to equal again? Okay, so x plus y plus b is equal to 180. So you do that. That was good. Then, let's ignore this triangle now. So I'm going to rub this out. I'm going to focus on just this straight line on this side. Here's a straight line, so I'm going to highlight it. That's a straight line. What's the angle in a straight line again? 180. So if I draw it separately, like Yuri said, this angle should add up to 180 degrees. Now you know part of it, which is from here to here, this was Z degrees. Now if I called this side B, that means Z plus B must equal to what? 180. Now what's cool is that if you think about it now, have you noticed that right here you said to find Z plus B equals 180, but if you want to find Z, isn't it just 180 take away B, right? So 180 take away B, or if you wanted to find B on this side, have you noticed B is also the subtraction of 180? Now, if that's too confusing, there's an easier way to see it. Watch this. So you told me Z plus B should equal to 180. True? If I go over back to this one, you told me x plus y plus b should equal 180. Now I'm going to write them both together. So Z plus B, they both have a 180. They both have a plus. X plus y, isn't that just meant to equal to whatever z is? Because if b is 30, this one has to be 150. But if this is 30, then these two must still add up to 150. That's why, logically, we then say, well, then z must equal to x plus y. Can you see that? So I did it separately. I did one on this side, so a straight line. You told me it was z plus b equals 180. Then I did the triangle, and you told me b plus x plus y was also meant to go to 180. But if you do a comparison right now, it's pretty logical to say, well, that's plus b, that's plus b, that's 180, that's 180. These two must be the same. So whatever z is, x plus y must equal to that. So that you add on b to equal to 180. So that theory comes from this idea, z is equal to x plus y. Now, if you didn't get that, it's okay. You don't really need it. It means that you can still go through this method and still solve it. But I'm just saying there will be some problems that requires you to know that fact. Okay? All right, team. Let's do some problems together. Here we go. Example 1, A should be a straightforward one. This is a triangle. Yes? Okay, but I want to know how you got that. So William is saying A equals 57 degrees. Can someone give me the calculations to check if William is correct? What do you do? Yuri. Yep. Which is 133. Good. So I'm just going to spell out what Yuri is trying to say here. If you add all the angles together, it should equal to 180 because it's a triangle, three-sided shape. We know that 110 plus 23 is equal to 133. And why did Yuri say 180 take away 133? It's because I know A plus 133 is meant to equal to 180. The leftover you can work out by doing 180 minus 133 to see the leftover. So the quicker way to there, if you have a calculator, you simply type in A equals 180 minus 133. And that should give you, I don't think it's 57 actually.
It's 47.
It's 47. It's a good thing we double checked, hey? So there we go. So 180 take away 133 is actually 47 degrees. And this is what I mean, question, method, answer. Okay, so lay out the problem, do the calculations, think through it, and if you did make a mistake, you can pick it up as we go. Yeah? Next one. B. Now, in order to do B, the problem is that, yes, they've given you a triangle, but they haven't given you all angles. So what do you do here, Losalia?
Since there's like two lines on both sides, A must equal to the missing angle. That's so you do 180 minus 48, which equals 132, and then you divide by 2, which would equal to 66.
Is it 66? Yeah, it is 66. All right, let's break down what Losalia just said there. So how do we know this angle here is A? Well, yes, it is an isosceles triangle because it has two sides of the same. Again, like I said, isosceles should have a symmetrical line. Find it. It's not always going to be this shape. Sometimes they rotate it. Cut it in half, then you know which sides are symmetrical. So if this is A, that definitely had to be A. Putting it all together, we know that A plus A, so angle A plus 48 in a triangle should add up to 180. 2A, A plus A is really just saying double of A. Okay, so you're doubling it. So you can think of it as 2 times A plus 48. But what I don't know is something plus 48 has to equal 180. And that's why Losalia said, let's do 180 take away 48 to see what's left over. So 180 take away 48, she's done the calculations, and that is correct, 132. And then 132 is meant to be equivalent to double of a number. So instead of doubling a number, we're now trying to go backwards. We're saying, well, let's divide it into 2 to figure out what 1A would equal to. Dividing by 2 does equal to 66 degrees. But the first skill there was that you needed to know this is an isosceles triangle. And then once you know it's an isosceles, you needed to know where to cut the line to say it's symmetrical. One of the common mistakes that I see students do is that they always think it's left and right. And that's why I purposely, in my test, I rotate it. I do this. And then I purposely do 48. And then some students will then say, 48, 48, find A. That's where they go wrong. I do that on purpose. I rotate the shape because I want to see, do they know this is the middle line? Therefore, that's not 48. That has to be an A there for these two to be equal, and 48 was the top. So just be careful. Find that middle line to cut it in half. Otherwise, you fall into that common mistake that students do with isosceles triangles. Yes, that's right. These two. That's right. So you look for those two lines, and it's the center of those two lines. That's how you know. So with these two lines here, I put a dash. It should be in between it, not this one. Okay, that's a common problem that students do. They usually cut this way, but it's about looking for the two lines, find the middle of it, cut it in half, make it symmetrical. Okay? All right, flip over the page. Let's try some other problems. 2 ways to solve this problem, but obviously one is quicker. The formula I gave to you guys before. Exterior angle. If this is 161, what do we know again? What's the rule say? Good. They all have to add up to 180. So the interior angles, these two add up, will equal to 161. Now that little box there, that means what? 90. So 90 plus something needs to equal to 161. To work out A, just find the difference. 161 minus 90. 71. Oh, you did. Oh, yeah. You could have found it this way. So you could have found this angle and then added all that. So that's the second method. So these kind of problems you can do both, but there is a reasoning question where you have to know the exterior angle to answer the question. So there's multiple ways of solving it. The quickest way was to know the exterior angle theorem. Okay. Alrighty. 61. Cool. All right. Last example for today. D. What type of triangle do we see here? It is a triangle and an isosceles because there's these two dashes. And again, like I said, find the cutting point. Here's the cutting point. That's the cutting line. So it must mean this angle 72 is equivalent to, which one? Is it on the left or on the right? Is 72 equal over here or is it equal to the, so this is the right and this is the left? To the right. Very good. So this top half should equal to that. Symmetrical. Not this one and this one. Okay? So now that you know this is also 72, then you can figure out what this entire angle should be here. 72 plus 72 is 144. So then this must equal to what? Well, yeah, each one is 23, but I want to know the total. 36. Okay, so it's 36 because that's 144. I need 36 for this entire corner here to add up to 180. So 144 plus 36 needs to equal to 180. But remember, since I only got half of it because it's symmetrical, that A is half of it. So I need a half to 36. And half of 36 is 18. So each one should be 18 degrees. Okay? So that's where it's a bit tricky with the isosceles. Just got to find where that middle line is. Okay, if you can find that middle line, then you shouldn't make a mistake with the isosceles problem. Otherwise, yeah, depending on where you put the 72, that's where your answers could be different. Okay? Alternatively, you could have also done 90 plus 72, and then 180 take away that will give you the leftover as well. That's another way too. Okay? All right, team, I'm going to stop the video there. That was 18 minutes of my explanation. You have the rest of the sessions 2:23. So that's almost a good hour. You get at least 50 minutes to work on 2B, 2C, 2A. Or remember, 2A and B is due by the end of this week. And I don't see you until Wednesday. So I'll be checking. Checking Wednesday.